Example problem number 1, section 6.4. The pre-lesson was a doozy. So let's try to solidify this. On your mark, get set. Let's go. The problem says graph the function y equals the natural log of x. So this is the first time we've seen this. So we've got to talk about it. A little different than the pre-lesson, but you're going to quickly see the similarity, I hope. It says then graph the inverse function. Well, hopefully you've got some tools in your toolbox now to attack this, but let's talk. What I did is I just kind of threw some numbers in here strategically. I want to talk about this. Now, this is a problem where you can take your calculator and join me if you want, but I'm going to actually put -2 in for x, take my calculator, and I'm going to go the natural log of -2. Oh, one thing, make sure to hit the negative button when you're doing negative numbers. Don't hit the minus. Your calculator won't understand it. And then I hit enter. Look at that. You probably can't see it, but it says error. It's giving me a bunch of business. How come? Well, I'm going to explain that. So if I put -2 in for that x, my calculator is saying, no, you didn't. So why is it telling me that? And this is just, I'm throwing this in for free because I want you to really understand logarithms. So that little e isn't there, but when you see the natural log, there is an e. So that's why I put it there. And if I just say, oh, what does this mean? It means e to the y power equals -2. Right here. Well, what is e? 2.71. So the calculator is telling me that you can't raise 2.71 to any power and get -2. Makes sense. How could I go 2.71 times itself a number of times and get a negative? It's not going to happen. So this is gone, this is gone. It's talking about, like, what's the domain? See, the negative x's are not part of my domain. It's not part of my drawing. What about this 0? Well, if I put a 0 in there and I bring it along for the ride, how could that happen? So that's why, and if I plug this guy in, let's see, I did it on my paper, negative, what does that say? I gotta get my glasses on here a second. All right, got my glasses on so I can see. So I typed in 0.01 here. So I took natural log 0.01, enter. I got -4.6. There's our buddy. There's our anchor, 1, 0, always. So even if it's a log 2x, it's going to go through there. So just get used to that. And then 2.69, zip, 10. I just grabbed some random things. I wanted to get a bigger number so you can kind of see what happens that way. It only goes up 2.3. So my drawing will look like that. Now this goes up, so I hope that doesn't confuse you. But do you notice it's the same thing as this-ish? So after you've done a bunch of these, do you really need to do this? No, you don't. Okay. Now, the next question that they're going to ask us is to graph the inverse. So I'm going to grab my red marker, and it says graph it. So you've got a couple of techniques. So what I could do is take these and just switch them all and just graph those spots. So I'd go, okay, let's start with -4.6 to 0.01, and then 0.1, and then 0.692, and then 2.310, and graph these. So let's start with this, 2.310. 2.3 would be here, 10 would be somewhere, I don't know, I'm guessing up here. 0.692, so that's almost a little over halfway, and then up 2. So 2, I'm going to stay right there. And look at this, 0.1. And then I think, oh, I think I get this. -4.6234, wait, 4.6 would be right about there. That's barely above the x-axis, so you can see what's happening. And I know what some of you are thinking. You just made that hard. Okay, but that's really what's going on. Because another student's like, well, you taught us that trick. You're right. All I had to do is take the purple one and flip it over the y equals x line, and it works every time. All right, I think you're getting it. First problem in your example problem set was more of a graphing concept. Now we're just going to do the mathy math concept. So it says find the inverse. So don't forget, that means you're looking for this, and there's a process. So the first thing we're going to do is just realize that this is the same thing as this. Second thing we're going to do is switch my x's and y's. So here we go. X equals 3 to the y plus 2. You just flip the graph over the y equals x without even knowing it. So this is where we really make a break. Everything up here is f of x. Everything below is the inverse function. But we're not done until we solve for y. Notice where y is? Up in the our exponent is where our logs come into play. So log of x equals log of 3, and that's all raised to the y plus 2 power. That allows me to bring it into the front. So log of x equals, here it comes, y plus 2 times the log of 3. Now, remember, a lot of times we end up with log of 10 right there, which is just equal to 1, and not this time. So that doesn't equal 1. So like, okay, what do I do with that? Well, for years you guys have been doing stuff like this. 2x equals 8, you just divide by 2. You do what you need to do. This is just new looking for you guys. If I got to solve for y, and I don't want that here, I'm going to divide by log of 3, cancel, cancel. But I got to divide this by log of 3. Now, don't you start canceling these logs out, because if you did that, you'd be saying that's a 3. Remember, if you type in log of 3 right now, it's actually asking you 10 to some power equals 3. That's not going to equal 3. You can check it out on your calculator. So don't cancel those out. So I end up with log of x, log of 3 equals y plus 2. Now I'm going to subtract 2 from both sides, spin it around, get used to things looking weird, guys. Log of x over log of 3 minus 2. Am I done? So close. Remember, as soon as we switch the x's and the y's, we no longer have f of x, we now have the inverse. So we've got to take that out, and there it is. So strangely, this is the inverse function of this. If they did ask us to graph it, it'd be quite a nightmare, but well, maybe not too bad. But anyways, we're not doing that this problem. Next problem. This problem says, find the inverse of this. So here it is again, you guys. Hopefully you're getting used to this. And it says, and graph it. Now I'm going to do this first, because I think it paints a picture of what you're actually doing. So I'm going to graph it first. So red marker, please. All right, so the first thing I'm going to think to myself is the parent function right here. Like, wait a minute, my anchor, he said, is 1, 0. You're right. That's going to look like this and like that. So what does this do to the red one? I'm going to use purple. That's what this is. I'm going left 5. So see that point? Remember, I know that point is 1, 0. Give me an anchor. I know I can move that thing left 5. 1, 2, 3, 4, 5. That's where that point went. And duplicating the top is not hard. This, you got to think a little bit. See, this right here is 1 unit left all the way here. So if I go 1 unit here, that's where the asymptote is, if you want to be super accurate there. Okay, so it's asking us to graph the inverse of this. All right, well, here comes my y equals x. Notice I made it longer. It gets confusing if you stop too soon, like right there. So you got to kind of make these longer, because then the inverse, see, I'm going to demonstrate what I'm talking about. See that right there? So I know this doesn't stop here, it keeps going. There's my y equals x. And the inverse, I'll do in green. Come on, green marker. So if I said, hey, I want to graph g negative 1 x, the inverse, I just take the purple one and flip it over the red. There it is. So this right here is the inverse. Now I got to do the mathy part. So this is my parent function just to get us kick-started. Now we got to take this guy, and it means y equals log 7x plus 5. Yuck. I got plenty of time. So I'm going to replace my x's and y's. And it's at this moment I'm finding this. So I'm going to make a little line there so my brain can understand what's going on. Now I got to solve for y. Well, I know if I just look at this, this is my base, this is my exponent, that's my answer. So 7 to the x power equals y plus 5. Subtract 5, subtract 5. I'm going to flip this around now. Y equals 7 to the x minus 5. But remember, it's this. So I'm going to take that out, and I found it. Now, interestingly, if I was to graph this, it would be that green line. I think it's fascinating. Short and sweet, this last one. Back to our basics. Describe. Doesn't say graph, it says describe, using our language of transformations. Now you might know what this looks like. There's my 1, 0, looks like this. But they're not saying to graph it, they're saying describe. So remember, this is built off a bx plus c plus d. This right here is d. So this graph would be that graph up 4. Done. This one, what is this? That's my A. Well, I have to describe. Will that be a vertical stretch? 5. Done. I threw this one in for free. How does this compare to that? Well, remember, it's just f of x flipped over y equals x. So if I was to actually go rip and then flip it, what would that look like? Uh-oh. Kind of like that. Terrible drawing, but we didn't have to graph it, just had to describe it. So there you go. I think you're ready for that homework. Good job, you guys.